In a previous video, we learned how to factorize quadratics when the coefficient, that is the number by x squared, was equal to 1. So in this example here, the 2x squared that we can see would have been equal to 1. We're now going to learn how to solve quadratics like this one, where the coefficient of x squared is not 1. Your first step is to multiply the coefficient of x squared by the constant term on the end of the quadratic expression. In this case, we have 2 times 5, which is just 10. We then write down a second quadratic equation, which is the same as the one that we have in the question, with the slight difference that the number on the end becomes the number that we just worked out, so in this case, 10. Our next step is to write down 2 brackets. In the brackets, our first term should be 2x, because the first term of the quadratic is 2x squared. We should write 2x as our first term in each of the brackets. The second term in each of the brackets is going to be very similarly determined as in the previous video, so we need to work out a pair of numbers which will multiply to give 10. That's the constant in the new quadratic that we've written down, but add to give 7. Considering the factors of 10, the numbers must be 5 and 2. Plus 5 and plus 2. We're not quite finished, because at the start of the process we multiplied by 2. We must now divide one of the brackets that we've written down by 2. Looking at the first bracket, we can see that the 5 is not divisible by 2. So we look to the second bracket and we divide this one by 2. Again, we're dividing by 2 because we multiplied by 2 at the start of the process. This will give us 2x plus 5 unchanged, but the second bracket will become 1x, which is just x, because 2 divided by 2 is 1, plus 1, because 2 divided by 2, again, is 1. And our factorized expression will be 2x plus 5 times x plus 1. Here's a second, slightly more tricky example. We want to factorize the expression 3x squared minus x minus 4. To do this, I'm going to first multiply 3 by minus 4, which will give me minus 12. And I will write down my auxiliary quadratic 3x squared, take away x, take away 12. I then write down my 2 brackets. My first term of each of the brackets needs to be 3x as opposed to x. I then need a pair of numbers which will multiply to give minus 12, but will add to give minus 1, because minus x, remember, is just minus 1x. So multiplying to give minus 12, adding to give minus 1, my numbers must be minus 4 and plus 3, because minus 4 multiplied by plus 3 is minus 12, but minus 4 plus 3 is minus 1. Don't forget now to divide. We multiplied by 3 at the start of the process, that's the coefficient of x squared. So we now must divide one of these brackets by 3. The first bracket isn't going to work because 4 is not divisible by 3. So I'm going to have to divide the second bracket by 3. This gives me a final answer of 3x minus 4 multiplied by 1x, that's 3 divided by 3, plus 1, 3 divided by 3 again. So my answer is 3x minus 4 multiplied by x plus 1. Here's a question for you to try. Pause the video now and have a go at it, and when you're ready for the answer, press play. Here is the answer. Let's go through a slightly more difficult example. As before, we want to factorize the expression, the quadratic expression, 8x squared plus 10x take away 3. We start exactly the same way. I'm going to multiply 8 by minus 3, that will give me minus 24. I'll write down my auxiliary quadratic, 8x squared plus 10x, take away 24. I write down my 2 brackets, the first term of both of which is going to be 8x. I need a pair of numbers that will multiply to give minus 24, but add to give 10, which is going to be minus 2 and plus 12. Now, if we were proceeding exactly as before, we would need to divide one of these brackets by 8. But as we can see, not all of the terms in the brackets are multiples of 8. The first bracket, I could divide my first term by 8, because 8 is a multiple of 8, but I could not divide the minus 2 by 8. Similarly, I could divide the first term of the second bracket by 8, but not the second term. In this case, we need to instead notice that 8 is equal to 2 times 4. And we need to instead divide one of the brackets by one of the factors, 2, and divide the other bracket by the other factor, 4. I'm going to divide the first bracket by 2 and the second bracket by 4, because I can see that the second bracket has terms, both of which are divisible by 4, 8 and 12. This will give me 4x minus 1 multiplied by 2x plus 3. And that will be my final factorized form. Before you ever go at some questions, let's have a go at solving a quadratic using this method. We have the equation 2x squared plus 7x plus 3 equals 0. Remember, whenever we want to solve a quadratic equation, be it by factorizing, completing the square, or the formula, it must first equal 0. So what I have to do here is multiply the 2 by 3, the coefficient, the constant term, and this is the same as before. 2 times 3 will give me 6, so I can write the auxiliary quadratic 2x squared plus 7x plus 6, and I want to factorize it. So I'm going to have 2x and 2x as before. I want a pair of numbers which will multiply to give plus 6 and add to give plus 7. Obviously this time we have plus 1 and plus 6. I'm going to divide one of my brackets by 2, because that's the coefficient of x squared. That's what I multiplied by at the start. So I'm going to divide my second bracket by 2, giving me 2x plus 1 bracket x plus 3 as my final factorized form. But if the equation at the start was equal to 0 when it was not factorized, it still equals 0 when it is factorized. So I have 2x plus 1 times x plus 3 equal to 0. So either 2x plus 1 equals 0 or x plus 3 equals 0. In the first instance, if 2x plus 1 is equal to 0, then I can say that 2x is going to be equal to minus 1 by subtracting 1 from both sides of the equation. I can then divide both sides of the equation by 2, giving me that x is equal to minus 1 divided by 2, which is just minus a half as my answer. On the other hand, if x plus 3 is equal to 0, then I can simply subtract 3 from both sides of the equation, giving me that x is equal to 0 take away 3, which is minus 3. So these are my solutions to the quadratic equation. Remember, it's perfectly normal for there to be two solutions to a quadratic, so you'd have to give both of these to get all the marks. Here are some questions for you to try. Please pause the video now and have a go at them, and when you're ready for the answers, press play. Here are the answers. Notice in questions B and C, we've needed to make the equations into the form ax squared plus bx plus c equals 0 before solving.